Hey, Chemsters, this is Mrs. Vanderwall bringing you the chapter 6.1 through 6.5 practice part 2. Hopefully you had a chance to look over practice part 1 and clear up any questions you might have, and so hopefully this went pretty well for you. So first of all, for each problem, write out all the products, label each as a nucleophile, substrate, organic product, and leaving group, and answer the questions for each of the problem. Well, first of all, I want to answer 1 and 2 before I put the answers in here. So is this carbon right here, is it primary, secondary, tertiary? Hopefully you all figured out it's primary. So is this reaction be SN1 or SN2? Well, I have a primary dead giveaway. All right, it's SN2. What else do you have? You have a primary substrate and a strong anion for the nucleophile, okay? So what are my products? I'm just gonna make bromine leave and put the cyanide in there and voila. So now I need to label it. All right, substrate, nucleophile, organic product, and leaving group, okay? All right, so will the R and S notation be needed? The answer is no. Why not? It's only for asymmetrical secondary carbons, okay? You don't have to worry about for primary. Rare occasions do you need it for a tertiary. That's if each of the carbons coming off of that central carbon are different. But we really won't come across that, at least not here in this class, okay? Let's go look at letter B. Okay, for letter B, let's kind of look at this first. Is this primary, secondary, tertiary? Well, how many carbons are off of this carbon directly? 3 of them. So, oops, it is, go away. There we go. It is tertiary. So is this going to be SN1, SN2? Well, folks, it's SN1. Why? Because all tertiaries are going to be SN1. What else do you notice? It has a neutral nucleophile. So let's go ahead and write down our answers here. Well, what I did first is I drew out the notation here into more of a three-dimensional, or you can kind of see what's going on here. So this is definitely a tertiary, and there's your leaving group. So here is our neutral methanol, all right? And now what do I make? Well, I get rid of the bromine and I put in the methanol group. So you notice I have that here, and notice it's a positively charged. And if you truly want to take off your H plus, you can go right ahead and do that. So now we need to label everything as being our substrate, our nucleophile. So here's my substrate, here's my nucleophile, here's my organic product, and here's my leaving group. Okay, so the only thing left is to answer this. Will R or S be needed? The answer is no, for the same reason as above. You only worry about it for the asymmetrical secondary. Okay, let's look at letter 3. Let's look at letter C. What kind of substrate is this one going to be now? Here's my carbon. I have 2 carbons off of there, so it is secondary. So is this going to be SN1 or SN2? I can't look at that. I have to look at this to determine. All right, and it's going to be SN1. Why? Because it's a secondary substrate and a neutral nucleophile. All right, so what do you think about R and S? Is R and S notation going to be needed? The answer is yes. Why? Because it is asymmetrical. So here's my carbon. I have a hydrogen, I have a carbon, I have 3 carbons. So definitely I have an R going. So what's going to happen here? How many organic products will SN1 have if I have to worry about R and S? I need 2. Think about what the mechanism for an SN1 is. The bromide will leave first, creating a trigonal planar. Therefore, your nucleophile can attack from either direction. So let's see here. Here's 1, all right, and then here is the other. Notice I have them attacking at different places. Okay, so what would this one be? Well, let's see here. It's my ABC, right? My smallest, medium, and largest. So what would this one be? Oops, that's going to be an R, isn't it? That's going around in the R shape. So what is this next one going to be? There's my ABC. So that is my, oops, my S. Oh, there you go. I can kind of see it there. All right, so there's my two groups. So I have two organic products. And don't forget, I have this guy right here. So how many products do I have? There I have it. I have two organic products and one leaving group. Okay, so what's the name of the game here? If you have an SN1 that's secondary, they have to worry about RNS. You can make two products. Why? Because in the mechanism, the bromide leaves first, creating that trigonal planar carbocation that the nucleophile can attack either direction. Okay, now real quick, if you want to remove the H plus from each of these, you can do that. I don't care. Okay, let's look at the next page. Okay, in letter D, just take a look at it. What kind of carbon is this? I have two carbons hanging off of it, so it is, whoops, it is a secondary, right? There we go. And so is this going to be an SN1 or an SN2? Well, I got to look at my nucleophile. It's negative, so it's SN2. All right, so I have a secondary substrate and a negative nucleophile. So will R and S notation be needed? Yes. Why? Because once again, it is asymmetrical. But how many organic products does SN2 have? You only have one. All right, you only have one organic product. If you think about it, the nucleophile attacks from the backside of the bromine, forcing the bromine to leave. So I have to worry about RNS. All right, so let's see here. Here is my ABC. All right, okay. And so hydrogen's A, one carbon is B, and three carbons are C. So what direction does this go? It goes in the R direction, doesn't it? So my product has to be in the S. Okay, so did I do that? Well, let's find out. Here's my A, B, C. Here's my OCH3. I left out my H's. So what is this going to be? I did make it the S. So I do have one organic and one leaving group. Okay, phew. Let's look at number 5. Don't know why that happened. All right. Here we go. So what about this carbon right here? I only have 2 carbons, so it is secondary. Is this SN1 or SN2? Well, it's going to be SN1. Why? Because I have a secondary substrate and a neutral nucleophile. So will your product be cis or trans or both? And your answer is both. Once again, I'll say it again. In an SN1 reaction, what happens is that the bromide has to leave first. So once the bromide leaves, then the H kind of comes down and makes a trigonal planar carbocation. So the NH3 can attack from either side, okay? So I'm going to make both products. So here is my first one, and here is my second one. Notice that this is my trans, and this is my cis. And don't forget, you have a leaving group. So I have a total of 3 products, 2 organic products and 1 leaving group. So what do you think is going to happen down here? Now, hopefully you saw where I was hoping that you could, let me get down here. Hopefully you saw where I wanted this to be something different, maybe for obvious reasons. Otherwise, it'd be another one just like number 5. I want to give you a little different one. So let's see here. Is this substrate right here, is it a primary, secondary, tertiary? Well, it's 1 carbon, 2 carbon, so it's secondary. And is it going to be SN1 or SN2? I wanted it to be, yeah, SN2. Why? Because I made it to have a secondary substrate and a negative nucleophile, okay? So what will my product be? Well, think again about how does this work. Right now, my substrate is trans. You agree? Here's bromide and here is the ethyl group, or not the ethyl, the ether group. So they are trans of each other. So what will my product be? Well, my OC is going to have to come over here from the other side of the bromine to knock the bromine out of the way. All right, so it will be cis. Why? I will have, let's see here, the cyclohexene with 2 groups on the 1,4 carbon, so SN2 will be the opposite. I will have one organic product and one leaving group. So this is my organic product, and I've lost, here we go. Here is my leaving group. So I didn't label this. This is my substrate, nucleophile, organic product, and leaving group. And I realized I left out something above. Hang on. I left out my justify my answer for both. All right. Will your product be cis or trans or both? Justify your answer. Cyclohexane with 2 groups of the 1,4 carbon SN1 will have a 50-50 mixture of both. Okay. Once again, this is my substrate, nucleophile, organic product, and my leaving group. Well, I hope you did well on that. That covers really every kind of situation in the substitution group that you'll come across. So we'll see how you do. Don't wait to be great. See you next time. Bye-bye.